in this identity we can clearly see that there is a single angle which is becoming double angle. Secondly, there are two terms. This is one term, this is second term. There are two terms which are becoming one. That means we have to merge them somehow. Tan A and cot A, they don't have anything in common, and it is difficult to merge them. So the best one is that we use the identities we know about tan and cot. So tan theta is sine theta over cos theta, right? And cot theta is 1 over tan theta, reciprocal of tan theta. So reciprocal means what will happen? We can write cos theta over sine theta, reciprocal of this. So these two identities we have to use, and one angle has to become double angle. That means we need double angle identities as well, and let me show it to them. Abracadabra. Here they are. So these are the identities I think will help us to prove this identity. So let's start with the left hand side. So tan theta must be converted to sine theta over cos theta. So sine A over cos A in this case, plus cos A over sine A. Now, if you want to merge the two, the denominators must be same. To do that, we should have their LCM, and LCM nothing but multiply them. That means I will multiply this by cos theta here, cos A rather, and multiply by cos A on top as well. Similarly, sine A over sine A. Now you can see the denominator here and denominator here are exactly same. Now they can be merged. Sine A cos A will be the denominator for both. This will become sine A times sine A sine square A plus cos square A. Now, we know this is also an identity. This is equal to 1 over sine A cos A. Let's see if it gives us the double angle because nothing else is left. And yes, you can see here, it is sine 2 theta equal to 2 sine A theta cos theta. That means if I write 2 here and 2 on top, there's no problem, right? So that it matches with this identity. And now I can write here 2 sine A cos A equal to sine 2A, and the top will become 2 now, not 1. And we can say 1 over sine 2A we know is cosecant 2A. So that becomes 2 cosecant 2A, because cosecant is the reciprocal of sine, that's why it became a proper identity, and this is equal to RHS. So we proved our identity. Well, in this identity again we can see that there are two terms and they have to become one, right? That means we should have something that combines them. We know that 1 minus tan square A does not result in any other trigonometric ratio. So what we can do, we can use again the identity which is tan theta equal to sine theta over cos theta. Now how is this going to help us? Because it will have a denominator. Because of this denominator we can merge the two terms and they become one. That will lead into something. So let's see. LHS is 1 minus sine square A over cos square A, because whenever tan is squared, sine and cos also are squared. So let me give them the same denominator now. So I will divide it by cos square A. So I have to multiply by cos square A here. So now I'll be left with cos square A minus sine square A over cos square A. Now, the denominator is cos square A. That means we have already gotten secant square A, because secant square A is, let me write here, secant theta is 1 over cos theta. Or cos theta is 1 over secant theta. They are reciprocal of each other. Now, let's look at this. If this gives us something, And for that, again, we need the double angle identities. Here it is. So we can clearly see here there is an identity which is cos square minus sine square, and that is cos 2 theta. Here we write cos 2a. And we know 1 over cos square is already secant square. We got it. Right hand side, we proved the identity. Again, in this identity, two terms are being converted into one term. That means again we have to convert them into fractions. So we will again use sine theta over cos theta equal to tan theta. So this will be sine 2a over cos 2a minus sine a over cos a. This is LHS, left hand side, right? Now we need to merge them. So we will write the LCM, which is cos 2a cos a. For that I have to multiply this by cos 2a and cos 2a. Similarly, here I will multiply by cos a and cos a, right? So now the denominator is same. Numerator will become what? Cos a sine 2a minus sine a cos 2a. Right? So what does that remind us? This one, compound angle. Remember this? Sine a minus b is sine a cos b minus cos a sine b. So we can see this. It is exactly this format. So sine a, the one which is first with sine, it comes first. So sine, this will come first because it is with sine. So it becomes sine 2a minus, and then b is what is with the cos a over cos 2a cos a. Now what does this give us? Sine a over cos 2a cos a. Now we can see this sine a over cos a is tan a, and 1 over cos 2a is a denominator. 1 over cos 2a will be secant 2a, because secant is the reciprocal of cos, and that is what RHS is. We proved the identity. This identity looks a little complex because there are big numbers involved, 3, 5, 4, right? And the angles don't match. So in such case, we know that cos a plus 3 sine a cannot give us a single trigonometric ratio. So best is we expand the LHS first. So let's expand this. So the expansion of cos a plus 3 sine a square will be cos square a plus 9 sine square a plus 6 cos a sine a. Now look, this 6 cos a sine a, look at the identity which is sine 2a, this one. If I multiply this by 3, it will be 6 sine a cos a, right? And that is here, and it is 3 here. That means we already got one part. So this is 3 sine 2a already. Okay, so we have to focus on these two now. We know cos square plus sine square is 1, but we have 9 here. So let's separate. Cos square a plus sine square a plus 8 sine square. What I did, I separated 9 into two parts. What is 1? 1 is 8. Because these two will give me 1. So that will be 1 plus 8 sine square a plus 3 sine 2a. Now, I want 4 cos 2a. Next one. Look at the cos 2a, which is in terms of sine square a, because that's what I have to convert. So I will look at this one, 1 minus 2 sine square a. So if I multiply it by 4, what will this give me? It will give me 4 minus 8 sine square a. Right? I have plus 8 here. So if somehow I write minus 4 plus 8 sine square a, that will be minus 4 cos 2a, and which is what we want, but it's not there. Minus 4 is not there. So what do? I need to change something. So how about this? I write minus 4 here and plus 4 here in front. So minus 4 plus 4 is 0. Actually I added 0, right? So minus 4 and plus 8 sine square a will give us minus 4 cos 2a, that was our requirement, plus 3 sine a sine 2a. It's already there. And what is 4 plus 1? 5. Voila. This is RHS. Got it. Here we have a combination of angles 2a and a again. Yeah? And we have to get in terms of a. In this identity, if you see, there is a cot, there is a tan, there is a cosecant, and there is a secant. All four are different, and it is difficult to connect them directly. So best would be that we take the help of sine and cos, which connects all of them. So let's focus on left hand side. So cot 2a is cos 2a over sine 2a. And similarly, tan will be sine a over cos a. Right? And now we'll use identities. Sine 2a, let's focus on the denominator. Sine 2a is 2 sine a cos a. So 2 sine a cos a. And I'm not sure what cos 2a, because cos 2a has 3 identities. Which one will be useful? We'll decide later. So keep it like this. So whenever you have such a thing, first effort should be to combine the two parts, because here both of them are multiplying, but here they're adding. So we'll merge the two and then we'll decide which cos 2a identity you have to use. So it will be here sine a over cos a. And now we need LCM. And for LCM, I multiply this by 2 sine a, right? That's how it becomes same as the left one, and 2 sine a on top also. Yes. So now the denominator is 2 sine a cos a. This will be cos 2a, and this will become 2 sine square a. Now if you look at the RHS, we have half cos secant a secant a, that we already have. 2 is a denominator, reciprocal of sine a will be cosecant a, and the reciprocal of cos a is secant a. So we already have our this part. Denominator has already this part. That means the upper, the one on the top, numerator should be equal to 1. And how can I do that? Let's look at the identity now for cos 2a, where I can cancel 2 sine square a. So this is the one. Can you see here? It has minus 2 sine square a. So I can convert this into 1 minus 2 sine square a, and plus 2 sine square a is already there, over 2 sine a cos a. That's the strategy. We should be aware about where we have to reach, and accordingly we take the decisions. And this cancel. We are 1 over 2 sine a cos a, and we know 1 over 2 and reciprocal. This is a denominator. Make it numerator by reciprocating, which is cosecant a. Similarly, cos a is a denominator. It becomes secant a, and this is RHS. This is another example where we have cosecant and cot, and they have 2a angles. So it's difficult to correct them directly because there is no square. So best is take the help of sine and cos again. So cosecant 2a will be written as sine 2a reciprocal of that, okay, plus cot 2a will be cos 2a over sine 2a. Oh, the best part is that both of them have same denominator, so we will write sine 2a here and the top will be cos 2a. However, we are nowhere near to where we have to reach. So since the angle is only a and we have here two a's, so let's convert them to a's. So let's start with the denominator, which is sine 2a, and for sine 2a we have one identity here, which will be 2 sine a cos a. Right? Now cot a, this is where we have to reach. Cot a is cos over sine, cos over sine a. Right? That means this sine a must remain, but this cos must go. Secondly, we have 1 here, this 1 must also go. So what do? We choose an identity out of the 3 identities of cos 2a where there is a minus 1, so that 1 goes, and there is a cos also, and which is the third one, this one. So we write 2 cos square a minus 1. So first purpose is gone, met, 1 minus 1 will be cancelled, and now we are left with 2 cos square a over 2 sine a cos a. So again 2 and 2 can get cancelled, cos, one of the cos will cancel with this cos, so we are left with cos a over sine a, which is cot a, and our aim is met. This identity we have secant square and cosecant square, which do not have any direct relationship with each other, and we want cosecant square. So we can use these reciprocal identities. So 1 over cos square a, 1 over sine square a, that will be LHS, right? So can I write this as sine square a cos square a? Yeah, so it matches with sine 2a. If you look here, sine 2x is 2 sine x cos x. So if I put 4 here and 4 on top, that should not make any difference, and now it matches with that one. So we can write this as 4 over 2 sine x sine a cos a square. Right? This one can be written as this way, and it matches sine 2a, 4 over sine square 2a, and which is 4 cosecant square 2a, because reciprocal of sine is cosecant. That is RHS. Here in this identity, LHS has a compound angle a plus b and a compound angle a minus b, and both signs are multiplying. But on the right hand side we have a subtraction. Yeah, it is not possible to convert a multiplication into subtraction unless we open up these compound angles. Alright, so let's do it. Sine a plus b, we will use the identity number 17, if you look at that, and sine a minus b, for that we will use the identity 18. So I'm doing that. Sine a cos b plus cos a sine b. This is the identity for the first part. It is being multiplied with sine a minus b. So it will be sine a cos b minus cos a sine b. Now if you look at the first term, it is exactly same as the first term of this bracket, and second term is same as second term. So we can use the identity we have learned in our earlier classes, that a minus b, a plus b multiplied will be a square minus b square. Yeah, so that is the same situation is here. This is a for us, this is b, a and b. So it will be sine a cos b square minus cos A sine B square. So this square can be applied to these both parts individually because they are multiplying, so it will become sine square A cos square B minus cos square A sine square B. Now look at your RHS. You have sine and sine. That means this cos and this cos must go. And how can they go? We can use identity number 5 for them. So sine square A remains sine square A, but cos square B becomes 1 minus sine square B. Similarly, cos square A will become 1 minus sine square A, and sine square B remains sine square B. Let's open the brackets now. Sine square A minus sine square A sine square B minus sine square B times 1 will be sine square B, and this minus will make it positive sine square A multiplied with sine square B. And now you can see this part and this part are exactly same, and they are opposite signs. They got cancelled and we are left with sine square A minus sine square B, and which is our RHS. We proved it. In this question, LHS is separated, but in RHS, both the parts have merged to become one rational trigonometric expression. So what should we do? Again, to merge the two parts, we should always multiply their denominators so that they have same denominator and we can merge them. All right, so let's do that. We'll multiply this by sine B. We'll multiply this by cos B. And we have to multiply their numerators, respective numerators as well. So what I'm left with here, sine B sine A plus cos A cos B, and that denominator, both of them are multiplying, so it will be sine B cos B. Alright, so on the right side we already see it is sine 2b. That means our identity number 12 will give us sine 2b if we have 2 here. So let's forcibly write a 2 here, and we will write a 2 on top as well, so that they cancel out and we have not made any difference to the expression. So the denominator is now sine 2b. 2 is 2. And now look at this, sine B sine A plus cos A cos B. Look at number 20. Cos x minus y is cos x cos y sin x sin y. It is exactly similar to this, only the order of the expressions is different. Here it is sin B sin A. Because they are multiplying, we can write it sin A sin B, commutative property, right? So it is exactly same. So we can write that here cos x minus y in that case, but here we have A and B, so A minus B. If question was here it was B minus A, that would also work. Not a problem. That means cos A minus B and cos B minus A are the same. But our RHS asked us to do this. We did this, and that's why it is proven. In this proof, we can see that we have one fraction of trigonometric identities and we want two separate terms out of them. Also, the angle here is simply A, and angles here are 2, is double the angles. So, since we need to separate them, this plus may help. This plus, we can separate the numerators with denominator. But for the separation, this cos A minus sin A must become one trigonometric ratio. Let's see if it matches with any one. And if I look at the list, it matches somewhere here number 13, identity number 13, cos square x minus sine square x. There is no square here, but it is becoming double the angle. So let's write LHS first, and because we know an identity which is a minus b multiplied by a plus b equal to a square minus b square, and that will make it cos square x minus sine square x if I multiply by a plus b. So let's do it. Cos a plus sine a over cos a minus sine a. This is our original rational term. Now we'll multiply it down by the conjugate of this, which is cos a plus sine a and cos a plus sine a. So basically I multiply this by 1, and now this and this will give me a square minus b square, like this. A is cos a, b is sine a. So it will be cos square a minus sine square a, that is denominator. And if you see numerator, they are exactly same. So basically we'll square cos a plus sine a. Cos square a plus sine square a plus 2 cos a sine a. This is the expansion of if I multiply this with this. So now we know cos square a plus sine square will be 1. And 2 cos a sine a. Look at the identity number 12. That is sine 2a. Over. Now look at this identity, and we started with this hint only. Number 13 gives us cos 2a. And we can separate them now. It will be 1 over cos 2a plus sine 2a over cos 2a. 1 over cos 2a, look at the identity number 2. It is secant 2a. Plus sine over cos. Sine over cos is tan, number 7. But the angle will remain 2a. And which is RHS. We have proved it. Well, in this identity proof, we have so many big numbers. 5, we have here 4, we have here 9, we have. So that means we need to do something so that it becomes so simple. And that simplicity will come only if a part of it gets cancelled out. This 5 should be reduced to 4 so that we can have some chance of cancellation. And all the angles here, the angle is A only. This is A, but this is 2A. So now we know that, look at the identities number 13, 14 and 15 here. We have to look for the one which will reduce this 5 and convert this cos to A into cos, because we have cos, 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 everyone. So I think the identity number 14 will do that, number 14. So let me do that. LHS. It will be 2 cos square x minus 1. So it will be 2 cos square a minus 1 plus 9 cos a plus 5 over 4 plus cos a. Now this becomes a quadratic, and this is not quadratic. That means we have to factor it. First, let's write simply 2 cos square a plus 9 cos a plus 4 over 4 plus cos a. Now we'll have to factor this numerator, so that one of the factors should be 4 plus cos a. So let's say 2 m square cos x cos a. Let's assume that cos a is m. So 2m square plus 9m plus 4. So I need to factor this. Okay, so these are the factors I got. M is cos A, so I will write cos A here. 2 cos A plus 1, that is one factor. And cos A plus 4 is the second factor, and you can see that 4 plus cos A is another denominator, so they can get cancelled now. They are exactly same. We are left with 2 cos A plus 1, and that is RHS. 2 cos A plus 1 to 1. Here we have been given an angle which is 4A, not 2A, not A, it's 4A. So I can write sine 2A times 2, right? So what I mean to say is this, sine 2 times 2A. This is what I can write sine 4A as, over sine A. That's your LHS. Now if I use the identity number 12, which says sine 2x is 2 sine x cos x, this times 2A is equivalent to x. Okay, so what will that be? 2 sine x cos x. 2 sine 2A cos 2A. Right? In place of x, I wrote 2A over sine A. Again, there is no chance. It's because this is angle A, this is 2A, so we can't cancel out anything. So let's use the same identity again to get this 2A into simpler form. So that will become was 2 times 2 sine A cos A this time. Yeah, half of the angle 2A is A, and that's what the identity number 12 says. Cos 2A. Cos 2A has three equivalents. So we'll wait for it. Okay, let's see. Keep cos 2A as cos 2A. We'll see which one will help us. Sine A was sine A. Now we can cancel out this sine A, it is multiplying. This sine A cancels, so we are left with 4 cos A. 4 cos A cos 2A. There is no denominator anymore. Now what do we want? We want cos cube. That means we need a cos square. Okay, number 14 is the one where we have cos square. So we will use number 14. So 4 cos A, that is equal to 4 cos A. And that comes up to 2 cos square A minus 1. That is identity number 14. And now we'll open it up and hopefully it will give us what we want. Cos cube A minus 4 cos A RHS root. Here is an identity where we have an angle of 4x, but on the left side we have just angles x. So it is difficult to create one out of this because 8 sine square cos square x. Does it match with someone? We can look here. Number 12. 2 sine x cos x. It matches with this number 12, but it has squares. So what can we do? We can separate 2 from this and write 2 sine x cos x square. That is the LHS I have transformed. 8 sine square cos square x can be written like this. Take your time, pause the video and see. 2 square will be 4, 4 multiplied by 2 will be 8, and sine x cos x. That's how it was matching with sine 2x. So what are we left with? This is sine 2x now. So we can write this as equal to 2 sine square 2x. Because square, because of this square, I wrote square with sine square, right? But still, there is no match with what is on RHS. There is one extra here. What about this? If I write 1 minus 1 plus 2 sine square 2x. I am forcibly trying to reach to 4x, okay? So what I did, I added 1 minus 1, which is 0. I added 0, kind of, right? So if I look at this part now, it matches with the identity number 15, 1 minus 2 sine square x. It is minus 1 plus 2. That means we have to take minus common here. So we can write minus here common, and it will become 1 minus 2 sine square 2x. Now it exactly matches with number 15. And we can write it as 1 minus cos is cos 2x. Can you see? So cos, but 2x is x is 2x here. So we have to write double of 2x, which is 4x, and that is RHS. Proved. So what is the learning in this particular identity? That look at the clues. It is giving you two words reaching cos 4x. It was reaching sine 2x, but we know that the sine and cos also have a relationship. So we will reach there somehow. Somehow add or subtract, do some manipulation, and you will get it. Okay, in this identity, the right hand side has doubled angles and the left hand side have single angles. So even if we expand this part, the left hand side, we'll need to add something more so that we get these numbers, odd numbers, 5, 3, 4. So it will make our job a little difficult. So in this identity is better to start with RHS, because simplifying something is easier than creating and making something big number, right? So I will focus on RHS. So let's write half outside and then 4, and sine 2a has an identity here, number 12, which is 2 sine a cos a. Yeah, minus 3 cos 2a. If you look here, I've already got sine, so let's talk about cos. If I get cos from here, cos 2a, and identity number, I think this one, number 14 will help. So I will write 2 cos square a minus 1 inside and plus 5. Alright, so half remains half again. This becomes 8 sine a cos a minus 6 cos square a plus 3 plus 5. If I simplify further, it becomes 8 sine a cos a minus 6 cos square a plus 8. Since they are even numbers, 8, 6 and 8, let's divide them by 2 so that this half goes. So we are left with what? 4 sine a cos a minus 3 cos square a plus 4. Right. Still we are not there. We are not. This is not a perfect square. We want a perfect square, right? So this is not a perfect square yet. So what will I do? I will multiply this 4 by, look at the identity number 4, sine square plus cos square. So I will write here sine square a plus cos square a, and that should give us something to play with. Okay, so 4 sine a cos a remains as it is. Now minus 3 cos square a and 4 cos square a will give us plus cos square a. Yes, and we are left with this 4 sine square a separately. This is the simplified version. Now you can see, if I expand this, the square of this will be, if I say this is a, this is b, so a square plus b square plus 2ab, that is the expansion. So it will give us 4 sine square a plus cos square a, that is a square plus b square plus 2ab. 2 times this, that will be 4 sine a cos a. And look at this expansion, and this is exactly same. So we can write this as 2 sine a plus cos a whole square, and that's how it has become equal to LHS, and we have proved the identity. In this question number 6, they have already given us a hint how we can prove this identity by expanding this and this. Alright, So let's take their hint and convert cos 2x into cos 3x minus x. Can I? 3x minus x is 2x. So we can convert this into this. Similarly, cos 4x will be cos 3x plus x. And now we have to look at the identities. And identity number 19 and 20 will be helpful here. So let me use the identity number 20 for this. It will be cos 3x cos x plus sin 3x sin x, right, minus cos 3x cos x plus, there is a negative in the identity. If you see, it has a negative, but because we are subtracting the whole of it, so the sign will change, so it will become positive here. Positive sin 3x sin x, and since they are exactly same and opposite sign, they cancel out and we are left with what they want. 2 sin 3x sin x proved. It is equal to RHS.